Hello, this is Christy Fowler from Yadkin Early College. This video is on sequences. So you have two kinds of sequences, arithmetic and geometric. With your arithmetic sequences, you're looking at the difference between consecutive terms is a constant. Okay, so basically you're adding the same amount to each term to get the next one, or you're subtracting the same amount from each term to get the next one. So if you look at your examples, you have an example of 6, 12, 18, and 24. You can see that you are adding 6 to each term to get the next term. Down here, what is not an example? 2, 4, 8, 16. So there, you start off, it appears that you could be adding 2, but then when you look at your next pair from 4 to 8, you're either adding 4 or multiplying by 2. So this is not an arithmetic sequence. You are not adding the exact same amount to each term. When you go to your geometric, this is where you have a ratio. Now when we talk about ratios, that means you're multiplying by the same amount each time. And remember, multiplication could be a whole number or a fraction. So that's what you're talking about with a ratio. So with geometric, you're multiplying. Okay, so in your example, you have 5, 15, 45, 135. What are you multiplying by each time? To get 5 to 15, you're multiplying by 3. 15 to 45, you're multiplying by 3. 45 to 135, you're multiplying by 3. Alright, so not an example, 15, 30, 45, 60. In this case, this would be a good example of an arithmetic sequence, but not a geometric, because to get from 15 to 30, you could either add 15 or multiply by 2. So you need to look at your next term, which is 45. To go from 30 to 45, you're adding 15. So in this case, it's not a geometric because you are not multiplying by the same ratio or the same amount by each term. Alright, so now we're going to talk about something called a recursive formula. You've actually talked about recursive formulas before. If you go back, way back to Math 1, when you did the now next rules, those are recursive formulas. Those are the ones where you just simply say, oh, I'm adding 3 each time, or I'm adding 2 each time. Okay, that's recursive. It's just straightforward. What do you do to get from one term to the next term? Now, in this case, we're not going to do now next rules, but it's still the same thing. It's just different symbols. So you got to look at these symbols that we now have. An arithmetic recursive formula, you've got a sub 1 represents a given value. Now, in all honesty, a sub 1 is your first value. A sub n is any value in the sequence. A sub n minus 1, if it's n minus 1, it's the one before a sub n. So usually you start with the first term, so your a sub n minus 1 here is typically going to be like your first term, and then you add whatever the difference is. The d is the difference, the common difference, okay? So in a second you're going to see an example, and this is going to make a little bit more sense, okay? But you need to know the terminology. So reference this slide again after it kind of clicks a little bit with some actual values, okay? A sub 1 again is the first term. It's got a 1 down there. N tells you the place in the sequence that a number occurs. So if you've got an A sub 1, that's your first one. If you've got an A sub 5, that's your fifth term. Your explicit formula is where you turn it into an equation or an expression. So that's where it kind of becomes more generalized. If reference back to your Math 1 days, you started off with your now next rules, and then you wrote things like linear equations, and you wrote things like exponential equations. Well, that's what you're going to do again. All right, we're just not going to call them linear equations, but that's what you're doing. So with the arithmetic explicit formula, take a look at this. You've got a sub n equals a sub 1, again your first term, plus n minus 1 times your d, which is that difference, that common difference. Look at the formula here. You've got a value all by itself, y-intercept. You've got a variable times your common difference, aka slope. Hello, there's your linear equation, people. Okay, so anyway, just pointing that out to you. Now, when you start putting some values in, what we're going to practice here in this example is writing an explicit and recursive formula for each sequence. So we have this sequence 2, 4, 6, 8, 10. This is an arithmetic sequence. All right, when you take the recursive form, again, your a sub 1, which if you want to think about it in terms of now and next, a sub n minus 1 is your now, okay? And then what do you do to the current term to get to the next one? You add 2. And that's going to get you the next term in your sequence. Then you always want to put where you start with a recursive formula, you always need to put where you start. And we start at the value of 2. With explicit, alright, you just substitute in your values. Remember, this is going to be your first value in your sequence, this 2. And then this 2 right here that you're multiplying by the n minus 1, remember that's your common difference. And since our common difference we were adding 2 each time, this is going to be a multiplication by 2. And then just n minus 1. Now remember, n represents the number in the sequence of where a number falls. So in our example, we want to check the explicit rule, so I just randomly chose, okay, what is the third term? The third term is 6. So a sub 3, 3 is for n because it's the third term in the sequence, equals 6. Substitute your stuff in. 3 is going in for n. Wherever there's an n, 3 goes. So you have 2 plus 2 times 3 minus 1. 3 minus 1 is 2, lots of 2's. 2 times 2 is 4. 4 plus 2 is 6. So our explicit formula is correct for this particular situation. Alright, these are some practice problems. Try to write your explicit and recursive formula for both of these sequences. The solutions are on the next slide, so go ahead and pause now. Alright, so your solution for number 1 is written up here in the top left-hand corner. These values are increasing by 1. So when you write your recursive formula, you're going to get a sub n equals a sub n minus 1 plus 1. And your starting term, a sub 1, is negative 5. Your explicit formula is negative 5, which is your first term, plus 1 times n minus 1. Alright, now over here in the green to your right, I have checked it for you so you can substitute in some random values or values from your sequence and check it out. Now number 2, everything is increasing by 7, so your recursive formula is going to be a sub n equals a sub n minus 1 plus 7. A sub 1 is your first term, which is negative 2. Your explicit formula, a sub n equals negative 2, which is your first term, plus 7 times n minus 1. Geometric sequences, you've got your recursive formula. Again, same kind of concept, it's just a little bit different. In this case, since we're multiplying, we're going to multiply in our recursive formula. Okay, R is the ratio, the common ratio between your values. In your explicit formula, remember where I mentioned the exponential equations? That's what you're getting here in your explicit formula. Alright, again, here's another example for your explicit and recursive formulas for geometric sequences. A sub n equals a sub n minus 1 times negative 3. That's your recursive because you're multiplying all of these terms by negative 3 to get the next one. A sub 1, your first term, is 5. In your explicit, you have a sub n equals your first term, which is 5, times your common ratio, which is negative 3, to the n minus 1 power. Practice problems. Pause the video here. Solutions are on the next slide. Here are your solutions. So in your first example there, you're multiplying by 2, so your recursive formula, a sub n minus 1 times 2, first term is 1. Explicit formula, 1 times 2 to the n minus 1 power. In problem number 2, since you're multiplying everything by -5 to get your next term, in your recursive formula, you're going to do your a sub n minus 1 times -5. First term is 2. And in your explicit, 2 times -5 to the n minus 1 power. Alright, so the reason you have your explicit formulas is so you can find any value in a sequence. So let's say we wanted to find the 25th term in these sequences. All you do, you substitute in 25 for n in your explicit formula. Work it out, and you're going to end up with your arithmetic sequence, you're going to end up with 50 in this case. And do the same thing over here with your geometric sequence. You can see here step by step you substitute in 25 for n once you have your explicit formula, and you end up with 33,554,432. Practice problems, 1 arithmetic, 1 geometric. Pause it here. Here are your solutions. Again, you just substitute in. You want the 32nd term, you substitute in 32 for n, work it out. For your geometric, you're wanting the 10th term, you substitute in 10 for n, work it out. See you tomorrow.